Hello, good morning, everybody. Today, another interesting uh, stations that I have taken to a study, and it's a one-year data. I have taken a Silk Board continuous ambient air quality monitoring station at Bengaluru, Karnataka, which is being monitored by Karnataka Pollution Control Board. This is also a non-attainment city declared by the Government of India. And I would like to explain in depth here more of which is the pollutant of concern and how to really approach to mitigate it. So that will be my main focus of this presentation. So let me straight away go into the presentation. So a brief insight of what is the continuous ambient air quality monitoring status in India. So there are about 518 continuous ambient air quality monitoring stations as per in India as per CPCB website, and about 804 manual national ambient monitoring program in 334 cities, 28 state and union territories. The frequency of this manual monitoring is 24-hour sampling for 2 days in a week and 104 samples in a year. That is the complete strength of that monitoring. While the continuous ambient air quality monitoring stations frequency is 15 minutes per data, 24 hours daily for 365 days, and the data availability is 95%. And the data strength is about 1,440 data per day, 43,200 data per month, and 5,18,400 data per year. And it is very minimally utilized, and it is used just for publishing air quality index. That's it. No detailed study on this beautiful data with such a high frequency is done in any state or any part or any committee whatsoever they have published. Use of this manual data is they are reconciling this data for 5 years and identifying non-attainment cities. This you can see in CPCB publications. So far, about 131 non-attainment cities have been identified. The critical pollutants of concern mostly in the country is particulate matters, which is PM10 and PM2.5. And most of the source apportionment studies in the country have said this. These particulates have originated from constructional dust, vehicular pollution, generators, etc., etc. So now, what is the problem statement and why to do this exercise and what we gain from this study? So I am going to give the problem statement here one by one and also the answers to this in this following video. Whether pollution happened in this monitoring location, critical pollutants of concern, which direction from which pollution was attributed and affected direction. So the root cause analysis. Is the pollution data is a representative to the location? And the cost of this establishment is about 1.25 crore and an operational maintenance cost about 3 to 5 lakhs. And just minimally used to publish an air quality index is not fair about. Issues and solutions. Whether additional parameters is required for this monitor or just the National Ambient Air Quality Standards monitoring. This is known to everyone, which is published in the National Ambient Air Quality Standards published by Central Pollution Control Board on 18th November 2009, wherein which continuous monitoring have been monitored for SO2, NO2, PM10, PM2.5, ozone, carbon monoxide, ammonia, benzene, while heavy metals and the benzopyrene are all manually monitored. So the real problem is this. The first statement, what I said, manual monitoring, annual arithmetic mean of 104 samples, twice in a week, 24 hours. This is what we are really doing in the country. The next standard or the prescription is, it is completely ignored or not followed or not given really a full-hearted adherence to this law. 24 hourly or 8 hourly or 1 hourly monitored values as applicable shall be complied with 98% of the time. They may exceed the limits, but not on 2 consecutive days of monitoring. I will show you from my data. I have also published many data from like Punjabi Bagh, Ghaziabad in Delhi, and Hyderabad, Punjab, Patancheru. All have shown exceedance in more than 98% and on more and on 2 consecutive days. Here we go into the monitoring. This is a time series plot of Silk Boat Bangalore. So you see all the parameters in one stretch. You will also see here, there is one line only going around here. This very clearly shows that the analyzer didn't work properly. That is, the parameter is SO2. So the purpose of and one-shot monitoring of a time series data of all parameters that has been monitored, we will know how these analyzers have functioned, and we will know how they have behaved. And also you can see there is an analyzer drift here at this time. That means at this frequency only these monitoring or the maintenance people look into the analyzers. That you can see from all parameters. There is a change in all parameters at a particular time. Most of the time, no one looks into the analyzer and data, and they are just paying it. It is a criminal waste. We should really look into very seriously. This is one point I want to address. And here is the PM10 exceedance for the standard of 100, 24 hours rolling average. And you see the red is the exceedance period from July 2022 till August. Till August, 14th August 2023, I have analyzed this data. This is the PM10 exceedance monthly pollution rows. So why I did this monthly pollution rows is to show from which all directions pollution has been attributed to this location every monthly. From which all directions they came. Now I'll go into the detailed part of it. Here, the PM10 exceedance, the number of days exceedance, and directional attributes. See in the month of July, the number of exceedance is 14. And the range of exceedance from 100 to 157.36. And the hour of exceedance, about 212 hours of exceedance have happened in that month alone. And it predominantly came from southwest, and the affected direction is northeast. Now the problem statement is answered here. When it got polluted, which month, how many times, and also which direction it got affected. Now what has to be done? The regulator has to go there, go to this direction from that location and identify which is the attribute to the problem and take some mitigation action. This is not done in any continuous ambient air quality monitoring station from the regulator side, nor the NGO or any group whatsoever happening. But I want to educate this as how to approach using this continuous ambient air quality monitoring, how we can really solve the problem then and there. So for the month of August, it is 15 times. And from the month of September 2002, it is 17 times. So it goes on. And up to August 2023, it is 11 times it is exceeded. Nearly all month is exceeded except on May 2023. This is more detailing, like what is the 50th percentile? 50% of the time, how much of data was available and from which direction it came. 75 percentile of the time and 99 percentile of the time. And from 50% it was southwest direction, 75% it was southwest direction, 99% it was southwest direction. So the overall frequency is southwest. So it's very clear. Southwest is the source for the contribution of PM10 to this monitoring location. So you have to identify what is the problem and where is the problem and what is the source that is emanating this problem in southwest direction attributing to this station. If you solve it, the pollution, this will be indicated in the monitoring station if this weather is reduced. You should not change the monitoring station from this attributing places. Today, I see many of the regulators, if they find that the pollution is higher or showing higher, in a particular station, they change the location itself and say, and put it under a tree or a very open area where there is no attribute at all, and say it is complied with. So this attitude must be changed. We must try to address the problem and see pollution is controlled to that area. So likewise, for every month I have done this, and we will see that in the month of November till March 2023, it is east predominantly. So east, so southeast, you can see in the 99th percentile. So it is mostly east. So southwest, east, and it is changes to southwest. This is the frequency in which the wind has and the wind speed has an directional pushing attribute of PM10 and causing an effect in the downward direction of northeast. So detailingly, I have taken 4 exceedance days. So there are about 15 exceedance days in the month of July. I've just taken only 4 days, and I've also given a detailed study to show that how and what time this pollution is happening. And you can see that it all came from southwest only. So I'm just not saying the number of days in a month. I have also detailed the number of days. And also, I am also showing out each day from which direction it is coming. So, isn't that the pollution from this direction can be mitigated? Yes, because you don't have the approach to know from which direction it came, you are not able to address. Now, the data from the continuous ambient air quality shows very clearly the direction from which pollution is being attributed. It is only going to that location, finding out the problem and eliminating it. This is PM 2.5 exceedance of the rolling standard of 60. This is the monthly pollution rose of PM 2.5. And this is the same story which goes for the number of days of exceedances and the directional attributes. And you see PM10 has exceeded on the month of October, November, and December 2022, and followed by Jan, Feb of 2023. And thereafterwards from 5th, that is May, till August, there is no exceedance. This is again the detailed analysis of the 50th percentile, 75th percentile, 99th percentile, and the directional attributes and the most frequent directional attributes of PM 2.5. And also here for the month of November 2002, I have taken the exceedance period of PM 2.5 and it is showing from which direction it is coming. It is southeast. So you have to attribute the southeast direction is the attribute for PM 2.5 in this monitoring location. And also I studied the day-night study. You will see during the month of September and November and during the month of July 2023 and August, the days frequency is more. In May, it is more or less equal with respect to day and night. But in the winter period, after September, October, November, the night concentration is increasing and it is lesser than the day. So this is also another lookout of whether pollution is happening at night or on day. I also did a top 10 concept of which month is highly getting polluted. I find that August 2023, 56.17, followed by September 52.92, October 49.53, and so on it goes. So this is the top 10 concept of highly polluting months to the least pollution months that I have also identified in this location at Bengaluru. This is the percentile rows, as I've earlier mentioned in detailed data. This is from as a rows that I want to represent as a single view as what is the 50th percentile, 75th percentile, and 99th percentile, which came from which direction with respect to PM10. NO2, 24 hours rolling average of 80 standard, it didn't exceed at this station. SO2, the analyzer was not functioning, and that is what you see for the whole period, except it start working from this after July 2023. But most of the time, the analyzer was not working at this station, and it complies to the standards. CO, yes, 1 hour rolling average of 4 milligram per meter cube. It has exceeded the standards, and it is more detailed in my report, which I am also going to publish. And got zoomed up. Okay. So the 1 hour CO and the 8 hour CO, there is exceedances. But one is the observation is you can see there is a drift in the analyzer. There is a drift in the analyzer. The drift in the analyzer shows that the 0 point of that analyzer is changed to a higher value and indicating at exceedance. So a continuous monitoring station needs a look into the analyzer, standardization, 0 and span drift has to be checked daily for a very good data. That is not happening in Bangalore. That is what is my inference. And ozone data is very poor. The analyzer is not functioning. That is what I see. And it complies to the standard of 1 hour rolling average and 8 hour rolling average of 100. This is another important work that I've done here with respect to PM10, PM2.5, NO and CO diurnal plot. So what is this diurnal plot? Diurnal plot is for the whole period from July 2022 to August 2023, every hourly what happened with respect to these parameters. So if you take the parameter at 9 o'clock, every day at 9 o'clock, what PM10 level concentration was there. The first day, the second day, the third day, up to all the 365 days is collated. So PM10, PM2.5, NO and CO are made into a standard scale and compared to find out what sort of inference that is giving. I find there is 2 peaks that has been happening, first peak and second peak. 2 peaks are indication of human is the cause for pollution. That means human activity at a particular time is only the cause for PM10 and PM2.5 to be attributed. And at the very same time, NO and CO has also been attributed. So this is very clearly showing that vehicular is one of the main root cause for PM10 and PM2.5 to be attributed at this station of Silk Bowl. I did one more work. Instead of NO, I took SO2 to know whether there is fossil fuel combustion is also happening. I find it is also yes with the minimal data available also. I have the analyzer, if it had worked fully means I would have had some more better information, but still it is showing some inferences with respect to PM10 and PM2.5 attributed through a combustional source and fossil source has also had a little attribute to PM10 and PM2.5 in the ambient air at the monitoring location at Silk Bowl. This is a correlation heat map. So to more explain what is the relationship within those 2 parameters and how they have attributed to PM10. PM10 and PM2.5, we know it is having a high correlation of 0.68. CO and benzene, they also had a positive correlation of 0.82. SO2 and benzene, moderately. NO and N2, 0.28. Again, a positive correlation. CO with respect to the time of our 0.31. Ozone and CO, but it is a negative, so it is not considered as a very good correlation. I did another deep work with respect to PM10. PM10 exists. What was the correlation of NO? It shows minus. That means not very high correlation. NO2 minus 175, not a very weak or a negative correlation. While SO2 0.159 with the available data and is showing a weak correlation. PM10 and CO, it is showing a higher correlation of 0.343. That means a combustional source is the cause for PM10 to exist in the ambient air. So this is called the root cause analysis. I did the same work for PM2.5 also. PM2.5 NO, a negative correlation. With NO2, a negative correlation. But with SO2, again, a positive correlation of 1.154. And with CO, about 0.135. Though it is a weak, but a positive correlation, this showing that if these data are betterly monitored and it is having a correct value image, still our root cause analysis can be confirmed as whether it is vehicular, constructional, or tire, or road dust, or resuspend dust is the cause for pollution. Thank you for your patience listening, and please share this beautiful information to all others. And let this education journey continue.